Three balls are launched simultaneously as in the figure. The red ball is launched at an initial velocity v sub o directed at an angle theta above the horizontal. The blue ball is launched vertically with a speed of 10.5 meters per second, and the yellow ball is launched horizontally with a speed of 5.2 meters per second. The blue and red balls reach identical maximum heights and return to the ground at the same time, and the red ball returns to the ground to meet the yellow ball at the same place along the horizontal. Find A, the launch speed v sub o, and the launch angle theta for the red ball. First, we need to identify what is given. We know that the vertical angle is 10.5 and the horizontal angle is 5.2. Because both of the balls went up at the same height, you can assume that both the red and the blue ball have the same speed going upwards. Same with the red and the yellow ball, since they both stopped and met at the same point, they both have the same horizontal speed, which is how we got these two speeds. Now, we're trying to find theta. We have our y and we have our x. So, since sine is used to represent the y-axis and cosine is used to represent the x-axis, we can use this equation, tangent inverse theta equals sine divided by cosine, to find this angle. So when you put 10.5 meters per second divided by 5.2 meters per second, you get tangent inverse theta 63.7. That is this. We have to find the initial launch speed. So even though 10.5 is our y-axis and 5.2 is our x-axis, what we need to find is this right here, which is along the angle. This could also be considered our hypotenuse. Now, given that, we use this equation, c equals the square root of cx squared plus cy squared, and we use the components that were given, which is, again, since 5.2 is on the x-axis and 10.5 is on the y-axis, we plug both of those in, and when you do that, you get c equals the square root of 10.5 squared plus 5.2 squared, and you get c equals the square root of 110.25 plus 27.04. That equals c equals the square root of 137.29, which equals c equals 11.7. Now, the final answers are the initial launch speed is 11.7 meters per second, and the launch angle is 63.7 degrees.